21 में हिप हॉप अंधेरे में था और हम दोनों टॉर्च थे, डबल और ट्रिपल पे शो बजाने पहुंचते। अपनी जिंदगी थिएटर, गॉड्स प्ले, गॉड्स प्लान, कोशिश मेरे हाथ में, मैंने कोशिशों पे कोशिशें ही की हैं। ये मेरा तजुर्बा है, मेरी असलियत यही है। मेरे टैलेंट पे सोया था पूरा शहर, एक वक्त था कि अपने भी लगते थे मुझे गैर। कुछ नहीं मिलना रैप से, बोले घर वाले, अब वो घर वाले कहते घर में स्टूडियो बना ले। वक्त बदलता है, you just gotta do you, खुदा सबका है, मत होना उदास यूं। तेज नहीं ज्यादा भाग बेटा, ये मैराथन है रेस नहीं, समझा बात। मैं राइम में एडवाइस दे रहा, लाइफ चेंजिंग। डिग्री नहीं थी डेडिकेशन से लाइफ चेंज हुई, दिख रही नहीं थी जो चीजें वो अब है नजर में। मेरा क्या बनता म्यूजिक छोड़ देता अगर मैं बांट दूं तो भी बचे मुझे 7 फिगर्स।
ग्रेट गेम। यार ये सब प्रॉब्लम देखिए मेरे फट जाते हैं। Mind of anagrams in a string. The substring with start index is 0. सब करूंगा एक एक करके। जब कर ही रहे हैं तो लाइक छोड़ के क्यों, करते हैं ना। समझ में आया ठीक, नहीं समझ में आया तो एटलीस्ट पता तो चलेगा क्या समझ में नहीं आया। और बस उससे सीखने की कोशिश करेंगे। चलो देखते हैं।
Hey everyone, welcome back and let's
एक चीज मैं नया करूंगा, मैं अब गूगल 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 डॉक्स की जगह मैं अब नोशन यूज करूंगा। नोशन ज़्यादा सही है ट्रैक करने के लिए। टुडुम टुडुम नीट कोड डेली चैलेंज CHALLENG नीट कोड डेली चैलेंज। क्या ये जनरेट करेगा अगर हम इसको बोलेंगे तो? मत करो प्लीज, हटा दो, वाहियात लग रहा। नीट कोड डेली चैलेंज। आज हम करेंगे क्राइट गेम। कैन वी टर्न दिस इनटू फुल स्क्रीन? ये गया इधर से, ये यहाँ पे आया, ये ऑन कर दिया। वाहियात लग रहा है। You're given a zero index. मजा नहीं आया, मजा नहीं आया। गूगल डॉक्स ही ठीक है। नहीं चाहिए। क्या कह रहा है? यू आर गिवन अ जीरो इंडेक्स 2D array wide of size 2 cross n। एक 2D array हमारे पास ग्राइड जिसका साइज है 2 cross n, where ग्राइड और c represent the number of points as a position, where ग्राइड r और c represent the number of position point RC on the matrix. Two robots are playing a game on this matrix. Both robots initially start at 0, 0 and want to reach 1, and minus 1. Each robot may only have to write R, C to R, C plus 1 और down R, C to क्या लिखा है यार ये? You are given a zero index 2D array. हमारे पास zero index 2D array है जिसका नाम है ग्राइड, जिसका साइज है 2 cross n। डोंट नो यहाँ पे n क्या है, ठीक है। n नंबर ऑफ शायद इनपुट्स होंगे। वेयर ग्राइड आर और सी, ग्राइड आर के आर आर 2D एरे है, तो फर्स्ट एरे के सीएथ एलिमेंट पे जो नंबर रिप्रेजेंट कर रहा है वो पोजीशन आर कॉमा सी है मैट्रिक्स पे। टू रोबोट्स आर प्लेइंग अ गेम ऑन दिस मैट्रिक्स, ओके। बोथ रोबोट्स इनिशियली स्टार्ट एट 0, 0, ठीक है, एंड वांट टू रीच 1 and minus 1, ठीक है, and want to reach 1 and minus 1. Move to the right. Each robot may only move to the right r comma c to r comma c plus 1, ठीक है। r comma c से r comma c plus 1, c plus 1 और down r comma c to r plus 1 c। At the start of game, the first robot moves from 0, 0 to 1 comma and minus 1, collecting all the points from the cell on its path for all the cells r comma c traverse on the path. Cried RC is set to 0, then the second robot moves from 0, 0 to 1, comma and minus 1, collecting the points on its path. Note that their paths may intersect with one another. Okay. The first robot wants to minimize the number of points collected by the second robot. The first robot wants to minimize the number of points collected by the second robot. In contrast, the second robot wants to maximize the number of points it collects. If both robots play optimally, return the number of points collected by the second. Fuck, क्या है ये? राइट है मेरे पास 254, ठीक है, 151, आउटपुट आएगा 4। वो कैसे? द ऑप्टिमल पार्ट टेकन बाय द फर्स्ट रोबोट इज शोन इन रेड, द ऑप्टिमल path taken by the second robot shown in blue. The cells visited by the first robot are the cells visited by the first robot are set to 0. Then the second robot will collect 0040 4 points. समझा नहीं मेरे को। ये कह रहा है the first robot wants to minimize the number of points collected by the second. The first robot wants to minimize the number of points collected by the second robot. In contrast, the second robot wants to maximize the number of points it collects. If both robots play optimally, return the number of points collected by the second robot. Points collected by the second guide 254, 151 to 254. The optimal part taken by the first robot 254 R comma C plus 1. ये है R comma C plus 1. ओके, ये फर्स्ट इंडेक्स से स्टार्ट होगा। यहाँ पे R R R ये अगर R हो गया, R कॉमा C प्लस 1 चल सकता है। R कॉमा C प्लस 1 अगर R 0 को डिनोट कर रहा है तो R प्लस 1 बेसिकली वही R में C प्लस 1, R में C प्लस 1 5 हो जाएगा। ठीक है, लिखता हूँ, देखता हूँ क्या कह रहा है ये। जो पार्ट ट्रावर्स हो गया उसमें हम 0 पॉपुलेट कर दे रहा।
Write some more neat code today. So today let's solve the problem grid game from this afternoon's Leak Code contest. So we're given a two-dimensional grid. It's 2 by n, so it's only going to have 2 rows every single time, but the number of columns in each row could be really big. It's going to be n. And we're given a little story about 2 robots. One robot is going to go, so it's only going to have 2 rows every single time, but the number of columns in each row could be really big. It's going to be n. And we're given a little story about 2 robots. One robot is going to go first, and then the second robot is going to go right after the first robot. The robots can move either down or to the right, and they're going to keep going until they eventually reach the bottom right position. They start at the top left and they reach the bottom right. And the first robot will go in a path where it will basically collect the values on each cell of the grid, and then once it's done that, those values will be turned into 0. So you can see before the second robot actually has a chance to go along the grid, the positions that the first robot reached have been changed to 0. And so the first robot wants to go in such a way that no matter what the second robot does, the second robot's maximum possible values that it can collect, the points it can collect, is going to be minimized. So what we're also told is that both robots are going to play optimally, and basically by optimally, the first robot, what it wants to do is minimize the number of points that the second robot can collect. And the second robot wants to maximize the number of points that it can collect. So the first robot wants to take all the good ones so that the second one can't collect them. But when the second one goes, right now you can see it has a choice. It has a choice of either going down this path to collect the 1, or it can go to the right to collect the 4. Of course, the second robot wants to maximize the points it can collect, so it's going to choose the 4. And our return value in this case is going to be how many points is the second robot going to collect if both robots play optimally, and now we understand what they mean by optimally. So this problem isn't super difficult, but there are some definite tricks that you really need to understand. You really need to understand what a prefix is and what a postfix is, specifically prefix and postfix sums in this case. And the reason is, you can see that the first and second robot are both going to travel in paths such that in the first row they're going to have some prefix of the first row, and in the second row they're going to have some postfix of the second row of each of the rows that were given, right? So if we wanted to go through every single path that the first robot could go, and what would be the sums of each of those paths, we can do that in n time, where n is the number of columns that we have, if we calculate the prefix and postfix sums, which is pretty easy to do. Let's just do that here. So in the first row, we're going to get the prefix sums. In the second row, we're going to get the postfix sums. So we can do that pretty easily with a single loop. We're just going to go value by value. Over on the left, you can see we have a 2 here, so we'll put a 2 here. Next, we have a 5. So we're going to put 5 plus the previous value, which is a 2. So we're going to put a 7 here. And then here we have a 4 plus the previous value, that's 11. So you can see that this 2 represents the prefix up until 2. This 7 represents the prefix up until the second element, and 11 represents the sum of the entire array. We're going to do the same thing for postfix in reverse order. We're going to have a 1 here, then we're going to put a 5 here. Now, your idea might be to be greedy, right? The first robot, maybe we can just be really greedy here, right? So for example, the first robot, it could either travel in a path like this one, or like this one, or like this one, right? And each of those paths is easy to get, right? Basically, if it changed directions at this index I, or maybe at this index I, or maybe at this index I, right? Basically, we want to know when that robot changed rows, because it can only change rows once. It can't go back up once it goes down. So you might think to be greedy, right? The first robot just takes the maximum amount that it can possibly do, and then whatever the second robot will try to maximize its points, and then we return the result. But that doesn't work in this case. That time complexity would be big O of n, but being greedy in this problem doesn't work. And to be honest, the way I figured that out was by failing the submission. But there is a better way to solve this problem. And it relies on a really small trick that you might gloss over. But take a look at this grid over here on the left. Notice how we go in some path over here right now. When we go in that path, we basically split the cells, right? This red line here split the cells. There's a group of cells over here, and there's a group of cells over here. All of the other cells, right, in this case, these zeros over here, right, they are no longer relevant, right? They're going to be 0. We can't really add them. But there's a group of cells over here and a group of cells over here that robot 2 can go. Now, we could have had a bigger grid, right? We could have had some more positions over here and some more positions to the left, right? But no matter what, take a look at this purple section, right? Like, let's say robot 2 or the first robot traveled along this, right? No matter what, there's going to be a group of cells over here or a group of cells over here, right, to the bottom left or top right. And the second robot can only collect one of these groups. It cannot collect both of them no matter what. And it's kind of obvious once you actually look for that pattern, right? Just by looking at it, how could possibly robot 2 collect both of them? It either stays on the top row or it goes immediately to the bottom row. It can't collect both of these groups. So what we want to do with robot 2 is basically check, okay, what's the sum of these cells? How could we do that easily? By using our prefix, right? We could take the sum of the entire row minus the prefix of just this section, and then that would give us the sum of this portion, right? And actually, as I explained this problem, I realized I probably could have solved this problem with 2 prefix arrays, right? There's probably not even a need for having the postfix. So that's probably how I'm going to code this up when we get to the coding section. But for now, you can just rely on the idea of a prefix sum. I think that'll make it simpler because this bottom left section, we can just get this area using the prefix sum. Right, that'll be pretty easy for us. And of course, the second robot will want to maximize this, right? So it'll take the area at the bottom left and top right, and we want to take the max of these 2 areas. And that's what the second robot will want to do. But we have to add an element of brute forcing to this problem, right? Because we want to know, no matter what the second robot does, if it plays optimally, what's the max number of points it can get. But the first robot wants to play optimally too. So the first robot, how is the first robot going to travel? It's kind of complicated, so we have to kind of brute force this. So what we're going to do is, suppose the first robot traveled like this. And how would we represent that? We would say I equals 0, meaning that the first robot basically changed rows at column I, which in this case is 0, right? That's one way it could travel. Or it could travel like this, which it actually did in the picture over here, right? It could travel like that, which would mean that it traveled on row I or column I equals 1, right? That's when it swapped rows. And in each of these cases, we would want to take, okay, the remaining chunk on the left and the remaining chunk on the top right, take the max of those 2, and that's what the second robot is going to want to get. And we want to run through each of these possible cases. So the last case would be this if the first robot traveled like this, and then the second robot would be able to collect this points, right? And among all of these possibilities that I just showed you, we want to return the one where the second robot collects the minimum number of points, because that's what the first robot is trying to do. It wants to minimize the number of points that the second robot can collect. So then this is how we do it. And if you notice, using prefix sums and postfix sums, if you really want to, you can calculate these amounts in O of 1 time, but obviously we do have to run through the first robot. It could do this, it could do this, or it could do this. It can go in each of these n columns, right? So the overall time complexity is going to be big O of n, because we do have to iterate through every single one of these columns. But other than that, the solution is pretty straightforward. Of course, we have O of n memory to store these prefix sums, but that's not too bad. So now we can jump into the code. Okay, so now let's get into the code. So the first thing I'm going to do is just take the dimensions of the grid, like the number of rows that we have, or rather the number of columns, which I'm going to assign to n. So, and then I'm going to do 2 prefix sums, one for each row. So prefix sum row 1, prefix sum row 2. Initially, I'm just going to set these to the clone of the grid row of each of these. So grid row 0, we can make a copy of that and assign it to prefix sum row 1 and do the same with the second row. And now we'll actually compute the prefix sum. So an easy way to do it is just like this in Python. So we'll just do a for loop going from 1 all the way to the end of each of the arrays. We don't have to start at the beginning because the prefix sum for the first element is already calculated, but it's going through every other element. So prefix at index I is just going to be whatever the value is already there plus the previous value that we calculated, right? Similar to what I showed you in the drawing picture. So we can just take I minus 1 and add that to there, and then we can just copy this line and do the same thing with the second prefix row. And now we're going to set our result initially equal to infinity. And remember, this result is the number of points that the second robot can collect. And initially we're setting it to infinity because the first robot wants...
खुला हुआ है. I was no. बोल ना. पानी के बॉटल में भाई तू यार। एक सेकेंड यार, सच
wants to minimize this. So it'll make a little more sense as we go through it. But so for